In this session, we want to think about scaling our decoder with more or less inputs. So I'll begin with the truth tables, logically, and say that here's my 2 to 4 decoder. So I'm going to make a copy of this, and then I'm going to paste it, drag it down here, and what I want to do is have one input. Now, if I have one input, there's only going to be 2 possible values for that, 2 possible combinations, so it's going to end up being a 1 to 2 decoder. And that means then down here that I could immediately say, oh, okay, I don't need all 4 outputs. I only need 2 outputs, and therefore there's only going to be 2 rows in the truth table and only 1 input. So here's my 2 to 4 decoder. And what we find is that C is not the input, B in this case, and D is the input. So all we really need is a NOT to implement a 1 to 2 decoder. For completeness, let's jump over to circuitverse and see that. So again, for clarity, I'm going to say copy all of this, and I'm going to make a new circuit that's going to be a 1 to 2 decoder, and I'm going to paste that in here and say that, okay, I only got 1 input. I'll use B like I did over there, which means this A input and that goes away, and I don't need the ands for C and D. Actually, maybe what I'll do first of all is say, okay, E and F are going to go away as well. We've only got 2 outputs. And what we can see is that C is not B, so that goes away, and it's simply that C is not B, and D is B. And so 0 selects output C, 1 selects output D. Pretty straightforward. We don't really need 1 to 2 decoders as discrete elements. We can just use a NOT if we ever need that.